Hello, I'm Dan Turner with GPM Controls. I'd like to go over today how you can charge accumulators, and a couple of things that you need to know before you can just jump right into it is you need to identify, one, the type of charge valve that your accumulator will have to it, and two, the type of nitrogen bottle that you're going to be tying into to get the pressurized nitrogen to come into your accumulator. We use nitrogen because it's an inert gas, and you don't want to put anything that has any oxygen or any potential flammable gases into an accumulator. So always use inert, and the most cost-effective, readily available gas is nitrogen. So we'll take the protective cap off, and at this point we see that we've got the typical 0.305 Schrader type valve that we're going to be using to charge the accumulator. This is the gas stem on this end. The bladder is inside of this, and this is our gas valve on our gas stem. So if you're just rebuilding an accumulator, one of the things you want to make sure of is that you've got a nice tight gas valve. So that's going to be very important to have that seal. The other thing you want to make sure of is that your insert inside your gas valve is properly torqued. Either one of those that would allow gas to escape from here is going to create a low pressure inside your bladder, and that will allow the bladder to be compromised by high pressure oil coming up and deforming that bladder. So we now know what type of a charge valve we have in our accumulator. We're going to take a look at our gas bottle. This is a 3000 psi gas bottle, so it will have a female thread on it, and our adapter will have a male nut and stem that will attach to that. If you have a 6000 psi gas bottle, you're going to have a male thread on it, and you're going to need a different adapter to be able to tie into it. Now, we use regulators for almost all the charging we do here. You don't often see regulators just because many accumulators are 3000 psi or less, and most people use a 3000 psi bottle. So in reality, there's never ever chance of getting too much gas pressure into your accumulator. So regulators are not always necessary. It's a convenience. It's convenient for us because a lot of times we'll charge them to just a very low pressure, and it's an easy way to set it, and it just happens on its own. So we've already got our reg attached. This is our charge setup here. We have a needle valve on the back. The bottle is already open, so we see we've got pressure on our gauge. Our regulator has been turned in, but we don't have a regulator gauge on there right now. And then we're going to come over to our accumulator, and this is your typical charge head right here. It's a very simple piece of equipment. You've got your gas chuck that actually just threads onto your Schrader type valve. You've got a little dump valve here that you can use to allow the gas to escape, and then of course you've got your pressure gauge. So you want to make sure that all this is in good shape. Make sure your gauge is in good shape. So you can use this type of head to charge and to check. So if we were just checking the gas pressure, we would not have the hose on it. This could just have a plug here at the bottom. So we're going to thread our gas chuck onto the gas valve. Just get it nice and snug by hand. Just take a small wrench. You don't need to get Gorilla on it or anything, just a nice little snugness there. And we're going to make sure that our T-handle on our gas chuck was turned counterclockwise so it is not depressing the stem on the insert. Now this accumulator does have some pre-charge already in it, so I'm going to close the bleed off. I've got my needle valve closed, so just by turning my T-handle on my gas chuck in, I see that I've got very close to 800 psi already in this system. Okay, so we've just checked that our gas charge is about 800, and let's say that our pre-charge is supposed to be 1000. At that point, we're going to want to add some nitrogen to the system. our bottle is already open. We've got our hose connected. The only thing we need to do at this point, since we're already depressed on our stem, is open our needle valve. So you can see the gauge is going up already, but be aware that just because the gauge hits 1,000 doesn't mean that's what's in the accumulator. As soon as I turn the needle valve off, the gas balances basically, and we drop back down to about 900. So we like to release the gas into the accumulator relatively slowly. If it's going in too fast, it gets very cold and can actually freeze the neck of the bladder and cause that to be very brittle. So you like to do just a very slow charge of nitrogen into the accumulators to avoid any chance of creating a brittle bladder. Okay, we're at 1,000 right now, so we feel pretty good about that. I'm going to turn my T-handle counterclockwise. So what that has done, it has isolated now our charge head from our accumulator. At that point, I'm going to bleed any pressure off. Right now, since my T-handle is turned out, I've just released the gas charge that's in my hose. So I'm ready to take my charge head off. Then we can put our valve cap on and then our protective cap. You do not want to see accumulators out in the wild without a protective cap on them. The same reason you like to see gas bottles always kept with their metal caps on. That needs to be cranked on just a tad bit so that nobody can just play with it and get it off. Next thing we'll do, just turn our gas bottle off. And I like to let the pressure off my regulator. So I'll just let everything go to neutral. Everything's in a good, safe position. Now that's easy enough with what we call the typical Schrader type valve. But what if you end up with a different type, like a European accumulator charge valve, and you're not going to be able to get to it with the standard gas chuck? We've got these really nice setups here. It's a very robust charge head, and it is comes with several adapters so that you can fit to almost anything. We've got different sizes of heads, and on this I believe we're at the 5/8. Oops, that's not the right thread. Actually, here it is. So we'll use this. And this has a hex that nests down into this adapter. So whenever we thread those together, and then we turn our handle at the top, it's actually rotating and making this stem go in or out. And if we turn it counterclockwise, which is how I like to start, you can hear a little click that we know we're fully retracted. So whenever we install this, we will not be depressing onto the gas stem. Now this head comes with 2 auxiliary ports. One would be for the gauge, and we would just pick, let's say, well, today we'll pick the low pressure gauge because we're just on like a small shipping pre-charge for this. Then the other adapter would be for the hose, and the hose is going to go on to our bottle adapter, at which point that would go into the port on the bottle. And then the way this system works is that this is our bleed off, so we can turn it counterclockwise to bleed any nitrogen off. We can be looking at the gauge while we're working this. We would turn the knob clockwise, which would depress the valve stem, and at that point we would be ready to fill this. Okay, so what I've done is I've hooked our rig up to the gas bottle, so we're actually ready to check this accumulator, the charge that's in here. This is a diaphragm accumulator, so we want to see what the pre-charge is. To do that, I'm going to have my bleed valve closed, and I'm going to depress my gas valve insert, and you can see that our gauge has gone up to about 300 psi at that point. And remember, right now we are using a 3500 psi gauge. We've got a 3000 psi rated accumulator. We've got a 3000 psi nitrogen bottle. So all the components here are rated for at least 3000 psi. I'm going to just be able to use the valve on top of the nitrogen bottle as my needle valve. Now I'm depressing my stem. I'm turned the whole way clockwise, and I've got my bleed off valve closed. So as I open my gas bottle, you can see that the gas is going into the accumulator. You just want to open it nice and slow. You're going to creep up. Right now it says we're over 500. To know that for sure, what I will do is I will open up. Right now I'm sealing the gas into the accumulator, dropping the gas off of my hose, and now I'm going to depress my gas valve in my accumulator, and I'm right at 500. If we only wanted to be at 400, we would keep the valve depressed, and we would let some gas off of our dump valve until we reach whatever pressure we want to be at, close it up, and at that point we're not being influenced by anything from the bottle anymore. We already know we've dumped that out. So now we can hear the click at that point, and again, there might be some on the hose left over from that last experiment, but again, if you want to verify, there's the pressure that we now have in our accumulator. So from that point, you're going to disengage it, dump the pressure, and everything should be in a safe state. You've already got your bottle closed off. You can remove your charge rig. Then you've got your cap with a seal. And everything's in good place. Now another thing I want to show you about this charge rig is not only is it good for the Europeans and some of the other more complex charging valves, but we also do have an adapter that threads into the 5/8 that we just used that takes you down to a Schrader type of thread. So we can use this same piece on the Schrader type valves as I demonstrated originally, and the stem in there is operated exactly the same with our knob at the top. So it's a very nice kit, nice and robust, allows you to do a variety of different accumulator charge valves, and it will last for a long time because of the way it's built. So there's how you charge an accumulator. Just wear PPE, make sure you've got your glasses on, make sure you use nitrogen, and make sure you use components that are compatible with the pressure that you're using. If you got a 6,000 psi tank, then use a 6,000 psi gauge. Make sure that all your needle valves, hoses, everything that you're using is compatible with that pressure of gas. If not, then I would recommend that you use a regulator to be able to knock that 6,000 down to a range where everything is rated at. So that's it. Thank you for watching.